We're looking at section 9.5. This is on page 264 in your student journal. Okay, these are some terms we're going to be saying throughout the lesson. An asymptote. We're going to be looking at vertical asymptotes. We're going to call them VAs. Vertical asymptotes are approached but not crossed. So these are going to be values that we're going to get closer and closer to, but we're never going to cross over them. The period is the x interval for which the function completes a cycle. The amplitude, this is the a value, just whatever the a value is of the function. And then I think we already know x-intercepts are just where it crosses the x-axis. So it's where the function crosses the x-axis. And transformation, these are just shifts, reflections, all that good stuff. Okay. Right here in core concepts, they're telling you everything that happens. I don't like to tell you all of it. I just want you to figure it out for yourselves. So we're going to come down here in the notes section, and we're going to kind of figure this out. We're going to be looking at y equals tan x. And we're going to be figuring out the rules for it on our own. So to do this, I want you to think of the unit circle. Okay? We're trying to figure out, based on some x values, what would our y values be. So I'm going to make a chart of values. We always want to go for 5 key points. On the sine curve and cosine curve, we went from 0 to 2 pi. But for tangent, it's going to be a little bit different. We're actually going to start at negative pi over 2 for one of our key points. The next one is going to be negative pi over 4. The next one is 0. The next one is pi over 4 positive. And the last one's pi over 2. It seems kind of weird to use these 5 key points, but after you see what happens, then it's going to make sense as to why we choose those for our x values. Negative pi over 2 means instead of going this direction, I'm actually going to go down. So I go to here. That's negative pi over 2. What's this point on the unit circle? 0, negative 1. Remember how tangent is the comparison of, it's the ratio of y over x. So what is y divided by x going to be? Undefined. When we have an undefined value, that means we have a vertical asymptote there. At negative pi over 4, this point right here, I'll just tell you, it's radical 2 over 2, negative radical 2 over 2. If I do y over x, what's that going to give me? Negative 1. Right here at 0, what's the point? So what is y over x? All right. Here's pi over 4. This would be the same as that, but it's positive radical 2 over 2, positive radical 2 over 2. What is it? 1. Pi over 2, what is it? And what's y over x again? Which is a vertical asymptote. And that's the reason why we chose to go from negative pi over 2 to pi over 2, because it hits all 5 key points over that interval. If I were graphing this, I would go to negative pi over 2, I have a vertical asymptote. I would go to positive pi over 2, I have a vertical asymptote. At negative pi over 4 rather, right there, I'm at negative 1. At 0, we're at 0. At pi over 4, we're at 1. And now I'm not going to cross these vertical asymptotes, but I'm just going to get as close to them as possible. And that's the way the tangent function looks. Let's look at it on our calculator, though. Go under y equals, and let's put in tan x. I want everybody to go to their mode. You can use degrees. Let's actually use degrees today. I just want to show you how it would still work. Go to degrees. Quit and do a zoom trig. Zoom trig will make it so that you can see the function. Can you see how this function goes on forever? So from negative pi over 2 to pi over 2, that's one cycle. Here's the next cycle. How far is it from negative pi over 2 to positive pi over 2? How far apart are they? How far? From negative half pi, positive half pi, how far is that? No, pi over 2 would be this distance, and pi over 2 is this distance. Pi units altogether, right? So if I went out another pi units, where would the next vertical asymptote be? If I added pi to pi over 2. Good. 3 pi over 2 would be the next one. 3 pi over 2. So let's say I wanted to go one more period. I wanted to draw that. Okay? Now, you have to be able to write the vertical asymptotes. Watch how we write this. The vertical asymptote is at x equals pi over 2 plus, how much did I add on to go to the next one? Pi. So I say plus pi k. K is always an integer. Can you see how if k is an integer, I would just add on 1 pi, or I could add on 2 pi's? See the graph? Here's if I add on 1 pi, I add on 2 pi's. It also could be what? Not positive, but negative. So wouldn't it make sense if k is negative 1? What's pi over 2 minus a pi? And isn't that where another vertical asymptote is? So this is the way I want you to write your vertical asymptotes. What about the x-intercepts? Here's an x-intercept here at 0. Where's the next one going to be? Pi. Okay, so my x-intercepts are going to be at 0, plus or minus pi, plus or minus 2 pi, dot, dot, dot. I could actually call my x-intercepts this, which would be more sophisticated, I guess you'd say. I could say it's pi k, right? 0 times pi, 1 times pi, 2 times pi, negative 5 times pi. That's where my x-intercepts happen. I want you to show you how you could check your table. Go to your second window. Where's our table starting? Negative pi over 2, right? But what did we put our mode in? So what should I call it instead of that? Not negative pi over 2, but negative, not 90, negative 90. And then how much am I going up by in degrees? Yeah, but in degrees. No. How much is it from here to here? 45, right? So now if I go back and I look at my table, see what it says? At negative 90, I have an error. That means a vertical asymptote. Negative pi over 2, which is negative pi over 4, rather, is negative 45. See how that all works? Okay? Let's go back to radians. Go to your mode. Go to radians. Now if I want to set up my table, where am I starting? In radians, what is this x? Right? How much are we going up by in radians? Pi over 4. And now look at your table and it should work. See what I mean? But watch now, if I go back, don't do this, just watch. If I go back to degrees and now I look at my table, see how it's all messed up? Because I haven't changed this to go along with the fact that I changed my mode into degrees. That's what I want you to see. All right, so that's how tangent works.
Is it doing like pi to, like it's doing 3.14 degrees?
Yeah, right. That's what it's trying to do, which doesn't make sense. So, okay, I want to flip over now to the examples, and I want to do just this number 3 example here. All right, so we're going to write down our key points for tangent. for a normal tangent function. Remember our key points. Where do we start? So negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. What's our y values normally? Right, so vertical asymptote. Think about this quadrant. This was quadrant 4, so it'd be negative 1.
0, 1, and 5.
Good. Okay, now we're going to look at shifts and transformations and things. Okay, so this is in front of the x, so pi over 4 in front of the x. Is that going to be a shrink or a stretch? Stretch. By the reciprocal of this, actually. Not 4 pi, but 4 over pi. Right. So what I would have to do then is I would actually have to multiply each of these x's by 4 over pi. Okay? So I'd multiply this by 4 over pi. What would that give me?
Pi over 2 pi 2.
Negative 2 would be that one, right? Multiply this by 4 over pi. What is it?
Negative pi.
No. Negative 1, right? And this one would be 0. This one would be what? And this one, 2. Okay, so we took care of that. What does this do now? That changes our verticals, and it changes our amplitude. That's called the amplitude as well. So I would multiply all of my y's by 1/4. So this would still be a vertical asymptote. This would be negative 1/4. See how that works?
So it doesn't affect the undefined.
No, because undefined times anything is still undefined. Okay, so now watch how I can check this. If I go to y equals, and I just type this in, 1/4 tangent pi over 4 x, all in parentheses. If I go and look at my table now, it's not going to look right. But that's because I didn't set it up. I go to my second table setup. Where's my table starting? How much am I going up by? 1. Now when I look back at my table, oopsie, let's hold on here. Oh, I went back to degrees. I have to go back to radians. There we go. See how it works? Undefined, negative 0.25. So see how you can always check your table, right? Okay, let's go over to cotangent now. Find a little space. Here's some space right here, good spot. This is on page 265 in the middle. All right, so now we're going to look at y equals cotangent x. Trying to graph that. So we're going to look at our unit circle. We're going to make a table of values. Now, I'll tell you this one, look at this letter right here. O. This is one that's going to start at 0. Okay, and it'll make sense as to why here in just a minute. Okay, and so we're going to start at 0. How much did we go up by every time on the last one? Pi over 4. We're going to do the same thing here. Pi over 4, pi over 2, 3 pi over 4, and pi. See, our key points are different because our period is now just pi and not 2 pi like it was for sine and cosine. So we're going to go right here. This point is 1, 0. Cotangent. Remember how cotangent is x over y? It's the reciprocal. So what is 1 over 0? Undefined. Which means I have a vertical asymptote at 0 now. Pi over 4. What's the cotangent going to be? 1. Pi over 2. X over y. 3 pi over 4. Yep. Okay, so see the difference? Now between 0 and pi is where we get all those values. So I'm going to graph these points. At 0, we have a vertical asymptote. At pi, we have a vertical asymptote. Here's pi over 2, pi over 4, 3 pi over 4. So I know at pi over 4, I'm at 1. At pi over 2, I'm at 0. 3 pi over 4, I'm at negative 1. I get closer and closer to these vertical asymptotes, but I don't touch them. Okay, so that would be what one period's going to look like. What's the difference? Look at the tangent curves. Those are going up. See how they're going up? And this one is going down. Look how this helps you. See how this has the O in its first vertical asymptote is at 0, right? And also this one goes down, right? And it's got that O in there. It goes down, and the other one goes up. Okay, I'm trying to give you some shortcuts here to make it easier when you have to graph. This one's down, the other one's up. Okay, so here's the way it looks. Let's just graph a bunch of them on here just to see that it is repeating. Cotangent is the reciprocal of tangent, so I have to do 1 divided by tangent of x. And I'm just going to do a zoom trig. So here's the way the cotangent curve looks. See how it's going down between 0 and pi. That's one of its periods. Here's another period, another. Okay, yep.
Can you not just do second cosine of x?
No, that's a way to find the angle. You cannot do that. That's the difference. See, here's the thing. Like, if I have a number like 3 and I push the x to the -1 button, that does the reciprocal, right?
Yeah.
But if I have tangent of, say, pi over 2, that's going to find the tangent of pi over 2. The tangent of pi over 2, that's going to be undefined. If I do second tan of something, that actually means to find the angle that has the given ratio. So it means something completely different. What you could do is this. Let me show you how this would be equivalent. You could type in tan x. Actually, all of that would have to be in parentheses, though. And then what key would I have to push? Not second tan, because that one finds the angle. What button would I have to push to flip this whole thing over? I wouldn't even advise you do this, but it's x to the -1. X to the -1 would actually take this function and do the reciprocal, the exact same thing as there. So now see how it's going right over top of it? See what I mean? They mean two different things. Second tan versus the reciprocal, which is this button. Okay, so we've got that. What about our vertical asymptotes? Well, they're going to be at x equals pi k, right? They can be at -1 times pi, 0 times pi, 2 times pi, 5 times pi. That's where our vertical asymptotes are. Our x-intercepts now, where are they occurring? Pi over 2. Where would be the next place it occurs? Say it louder, Henry. Okay, close. It's going to be at pi over 2. Did you say plus pi k? Okay, yeah, plus pi k. Okay, and that would mean plus, we can add on 1 pi, 2 pi, take away a pi, whatever. Okay? So there's where that comes about. If you want to read back, it tells you all that up here. Okay, let's go and practice a problem now, number 2. This is a cotangent graph, cotangent. So where am I going to start? 0 this time. My key point, 0, pi over 4, pi over 2, 3 pi over 4, and pi. Do you remember the key values here? What happens? Right, undefined, so vertical asymptote here. Next one. Next one. And vertical asymptote, right. Okay, so that's our original values. Now we're going to have to look at what happens. What's this going to do? Horizontal stretch by 2. So what do I do to all my x's? Multiply them by 2. Those would be my new x's. Okay, what does this do, this amplitude change? What does it do? It's a what? Vertical stretch by 2. So everything that is a y value is going to get doubled. That's not going to affect this, but it will this. Multiplying everything by 2. Okay, I'm going to go ahead and graph this one. So here's 0, there's pi over 2, pi, 3 pi over 2, 2 pi. So I know my, right here is going to be my x-intercept. Here's this point, and here's this point. And what's supposed to happen with this curve? It's supposed to be going what? Up or down? And it is, right? So that's the way that should look. I graphed one period, which is what the directions say. Describe the graph as a transformation. This is what I want you to do when they tell you to do it. It's just make your 5 key points. Let's go ahead and write the vertical asymptotes. Where are they?
0.
Well, 0, yes. Where else, though? So it'd be 0 plus, how much am I going to be adding on? So 2 pi k. That means I can add on 1 2 pi, 2 2 pi's, etc. K is always an integer. Okay? Does that make sense? Let's go do the vertical asymptote here. I forgot it. This one, vertical asymptotes are going to be at x equals -2 or +2, whichever you want, plus, what's the difference from here to here? How much am I adding on?
4 pi or 4k.
4k. Good job. Okay, so on your homework, guys, they are telling you to graph a lot of these. You don't have to graph every one. I just want to see the 5 key points, maybe graph 2 just to practice it. Okay? Make sense? All right.